Hello, Rich Halverson. This is ITS128, and today is October 1st, and I'm going to cover Chapter 5 today, or I'm going to start with Chapter 5 today. So let me share my screen. This works. And here is Chapter 5. And we just finished covering branching, and with branching, you have some sort of condition, and if the condition is true, then you execute the block underneath, or you execute the block. Let me find the simplest example here. Here you have a program, you execute something, you have a test, which is a condition. If the condition is true, then you do this thing. If the condition is not true, then you skip over that thing, and then you continue on, okay? So that's how a regular old branch works. Now, today, we're going to cover loops, and a loop, the basic loop, the while loop, is very similar to an if statement. The only difference is when you're done executing the block, you go back and you test the condition again. And if the condition is true, you do the block again. And then you go back and test the condition again. And you keep on testing the condition. Each time, if it's true, you execute the block. You keep on doing that until the condition is not true, until the condition is false. And when the condition is false, then you skip over the block and you continue on. So I've just shown you how while loop works using an if statement. So let's go to loops, and let's look at the lecture or the presentation they have here on loops. Okay, here's an example that starts out. The concept is, you're trying to put your baby to sleep, and so one thing that can work is you put the baby in the car and you drive around. The baby falls asleep. We used to do that. And so what you do is you drive around, and when you come to the intersection where you're either going to turn to go home or you're going to turn to take another trip around the block, you test. Is the baby awake? The baby's awake, and it's true that the baby's awake, and then you do the block, which is to drive around the block. But and then you test again. But if you test and the baby's not awake, then it's false, and so you skip going around the block. You skip around going around the block, and you just go home. Okay, so that's the idea of a loop. So here, you're adding up something. You're adding up a bunch of numbers until you read in a number and it's less than zero. If it's while a number is greater than -1, you add the number to a sum. Start out by setting a sum equal to 0. I'll make this a little bigger. You start out by setting a variable sum equal to 0, and then you get an input, and you store that input value into a variable called value, and then you come down and you test is value greater than -1. In other words, is value 0 or greater? In other words, is value not negative? If value is not negative, then we will add it to sum, and then we will go get another input, and then we'll come back around again and we'll do the test again. So we keep on doing this test. If it's true, every time, as long as it's true, we add the value that we just read in, we add it to the sum until we read in a minus number, a negative number, which is shown here. And at that time, this while value is greater than -1, that's false because it's equal to -1. And then we skip the block and we skip out and we continue on the past the block, on the other side of the block. So I would have drawn the diagram a little bit differently, but anyway, so that's so you can do this. So this is a fun thing. Okay, click increment if a negative value is seen. So it's kind of like we're going to be executing the while or the loop up there. So I'm going to start, and while it's negative, I'm going to click increment if a negative value is seen. So if it's count negative values. Okay, great. So if I see a negative value, I'm going to click increment. If I don't see a negative value, I'm going to click next value. Okay. Okay, that's next value, increment. Oh, next value. Okay, I messed up already. Okay, I got it wrong. Anyway, got that one wrong. So anyway, but a computer wouldn't make that mistake. Okay, so we haven't actually seen programming yet, and this is what the programming looks like. We have what? Okay, so this is an example of we are reading in. We're reading in a character here. We read in a character, and then we go up and we test to see if the character is equal to y. If the character is equal to y, then we do this block again. We do this block, and then we go back and we test it again. So you see how it's like an if statement where we do something, we test to see if something is true. If it's true, we do this block, and then if it's just an if statement, then we're done and we can go down here. But if it's a loop, specifically a while loop, then when we're done with the block, we go back up and we test again. So one thing about this is you have to make sure that inside the block, make sure you're doing something so the test variable, the test condition will change. The test condition will eventually be false. Because if the test condition is never false, then this thing stays in a loop forever. And of course, that's called a infinite loop, and you don't want infinite loops. So that's a while loop. So do we have any, so here's a while loop where you get an input, which is, oh, okay, you're reading, a program to do fit. You read an input, which is going to be, you enter in a character, a Q for quit, and then this looks at the, says user value is the 0th character that you read in. This is in case you actually type the word quit, for example, and really you're only after the first character of what the guy typed in. This is going to input a string, and we're only looking at the first character of the string. So this is how we look at the first character of the string. Anyway, so is the first character of the string a Q? In other words, is it true that it's a Q? If it's true that it's a Q, then this is false. By the way, Q stands for quit. So if they type in a Q for quit, then this is going to be false, which means this block is going to be skipped, and we're going to go down to here. Now, if the person types in something that's not a Q, that doesn't start with a Q, then this is going to be true. Because the first value, because the first character of what they typed in is not a Q. So if it's not a Q, then it does this block. Well, what is this block? Well, look, it's a bunch of stuff, and the last thing it does is it reads in another letter. Okay, it reads in another input, and it checks out the first character of that input. So this is pretty important to have this down here, because then you know that eventually the guy's going to be asked every time, and so you can quit the program by just typing in a Q. Anyway, so what is this? Well, this prints out the value, and well, you can see what it does here. It prints out these characters, and it looks like a face with a nose. All right, so you can trace through that. So let's go down and find some challenges here. Okay, so enter the output of the while loop. Okay, so let's start it, and we have G is equal to 0. And while G is less than or equal to 1, then do this. Okay, all right, so let's do that. G is starts out at 0, 0, enter. And then we're going to add 1 to G. So now G is equal to 1. And then we go back around. Is G less than or equal to 1? Well, yes, it is. It's equal to 1. So we're going to do this again. And so we print out G again. Oh, now it's equal to 1. And then we add 1 to it. And G now becomes 2. And we go back up here and test. Is G less than or equal to 1? No, not anymore. G is equal to 2. So we're done. Skip out and there's nothing left to do. So is this correct? Yes, it is. That's easy. Let's do the last one. Okay, so G is equal to 2. Great. Is G less than or equal to 7? Yes, it is. So print G. G is a 2. 2. And then add 1 to G. So now G is equal to 3. Is G less than 7? Yes, it is. So print 3, 4, 5, 6. Is it less than or equal to 7? After it prints a 6, yes, it is equal to 7 after it prints a 6. So we print that 7. And then we print the 7. 7 plus 1 is 8. Is G less than or equal to 7? Yes, it is. Wait a second. Is this right? Less than or equal to 7. No, it's not. G is not less than or equal to 7 anymore. G is greater than 7. So we're done. Is that right? I hope this is right. My thinking was wrong. Okay. All right. Well, that's pretty easy. Let's do the next one here. Okay, the while loop reads characters from input into a value called inval. Write an expression that executes the while loop character. The while loop while character E is not read in inval. Okay. Okay, so we are just reading in while E is not in inval. So we have to know if E is in inval or not. Well, how do we do that? We have to test to see. It's something like okay, we're testing to see if a character is in a string. Okay. So the test is E in inval. Well, I bet you that's something like if E, I bet it's that simple. But if E in inval, if E is in inval, and this is a comment, so this can just stay there, and then there's the colon. So if E is in inval, oh, wait a second. While E is not in inval. If E is not, okay, I'm guessing here. So we read in some word, and then while E is not in that word, do this. And then we read it again and we go back around in a loop. See if this is right. Oh, it's not right. Okay, what did I do wrong? Oh, what? Oh, I can't have those comments there? All right, let's take those comments out. Yeah, I guess you can. In another language, it might work, but not in this one. Sticking a comment in between. Okay, anyway, did I get this right? Okay, very good. So I guessed and I guessed right. Let's do the last one. This is read from input. It's a number. Write a while loop that iterates over while this is not negative. Okay, so while it's not negative, while user num is greater than or equal to 0 while it's not negative. That's not negative. That's greater than or equal to 0. While that's the case, update the value result as follows. If usernum is not divisible by 4, output hit and increment the result. Okay. If it's not divisible by 4, okay, if usernum mod 4, if that's false, I'm going to say this. Now, do I have to do capital? I think I have to do capital. In this language, I think false has got to be capital F. Okay. If that's false, then output print hit and then increment result. Otherwise, output miss and do not update the result. Otherwise, output print miss and do not update the result. Well, no, I have to, oh, then I got to read the next integer. Okay, that's a very important part. I was going, wait, it's going to be in a infinite loop if I don't have something there. So I'm just going to copy this and I'm going to paste it, not there, but there. Control V, paste. Okay, so it checks out usernum. If it's greater than or equal to 0, in other words, if it's not negative, then print this and increment result. Otherwise, doesn't do anything. So how does it know? How does it test if that happens? Okay, well, I'm going to test this, see if it's right. I don't understand how it knows if I got number 7 in there. Oh, of course, because it prints it out at the end. Okay, I didn't get all the points. Result is 2. Okay, so what did I do wrong? Let's see. So hit is true. This is true. Oh, that's hit. Oh, is this wrong? Oh, wait. I'm doing something wrong. Output hit and increment result. I did that. Put hit if the user number is not divisible by 4. While, write a while loop. Okay, what does, did anybody see what I did wrong? All those wrong. I'm doing something the opposite of what I should be doing. Oh, wait a minute. Oh, no, this doesn't make sense because the result of this should be a number, and the number should be 0. Oops, 0. If user mod 4 is 0, then we know it's divisible. Oh, then we know it's divisible. We want to do it if it's not divisible. So we want to do this if it's not equal to 0. Well, it can be greater than 0. So let's see if this is right. So I was thinking you would think of 0 as true, or thinking it's a true false thing. Of course, it's not right anyway, so I got the points. All right, very good. So what's okay, so that's so let's look at more while examples and see if there's anything interesting there. More while examples. Let's just go through this and see if there's anything fancy. Okay, so greatest common divisor. Okay, so this is just using a while loop to find the greatest common divisor in a number, and I don't want to bother explain. We'll explain greatest common divisor more when we actually have a greatest common divisor program that we have to write. But it's a way of finding the greatest common divisor between two numbers. That's a very important function when we do public key encryption, when we do encryption. All right, okay. While loop with a sentinel. Okay, what that means is that the sentinel is the thing that's going to make it quit. Okay, so you can have a while loop where you know beforehand or somehow there's a way, you're reading an input and it's pretty much a fixed number of input items, or there's some other way that you know that the loop is gonna that the iteration is gonna stop, or that the loop is gonna terminate eventually. If there's a sentinel, then what that usually means is that you're reading in a series of numbers, and there's going to be a number that means we're done. And that's, of course, is very useful when you don't know how many numbers you're going to read in. You might be reading in a bunch of inputs from somewhere or something, and you don't know how many inputs are going to be, but you do know that when everything is all done, there's going to be an input of a -1 or something like that, and then that would be called a sentinel, and that's how the iteration terminates. So let's just see what this is like. Let's see what this is. Okay. Oh. Okay. So we read in an input, and then we start. Okay. So what we're going to do is we're going to read in a bunch of numbers, and we're going to keep track of the smallest one. I think that's what we're doing here. We're keeping track of the smallest one. So we're going to read this number, and then we're going to read this one after that. Well, here's the approach. We're going to read in this number, and we're going to say, okay, the smallest number is 2. And then we're going to read the next number, and we're going to say, is this number smaller than the number that we already have as the smallest number? No. The number that we already have as the smallest number is 2, and this is 34. This is not smaller than 2, so we go on to the next one. Is this number smaller than what we already have as the smallest number? And the answer is no, because 12 is not smaller than what we have as the smallest number, which is 2. So then we go on. And then we read this 0, and lo and behold, this 0 is the sentinel, because this is the loop. It keeps on reading in a new user value, keeps on reading in a new one until it reads in a 0. So this 0 is not data. This is not part of what we're trying to figure out as the smallest number. This means there's no more numbers to read in. The last number that I gave you was the last number to look at. Okay, so what's going to happen is that this is going to write out the smallest number, because each time here it's going to keep track is this min value is what I currently have as the smallest number. Is the new value less than min val? If it is, then save that new number as the minimum value. Otherwise, don't. Otherwise, don't do this. Anyway, so the number is going to be 2, I think. What did I do wrong? Oh, I forgot. Oh, I forgot to put this in there. What is it giving me another chance? Okay, I guess it is. I didn't print this out. Two. All right, I got that one. What's this last one? Another sentinel problem. And this sentinel problem is we're only going to be looking at ages that are less than 16 or greater than 60. And we're going to keep on looking at ages that are less than 16 or greater than 60. We're going to keep on reading them in, doing something with them. If it's less than 16, it's going to do this. If it's greater than, wait, otherwise, if it's less than well, anyway, if it's less than 16, it's going to be a 5% discount. If it's greater than 60, it's going to be a 10% discount. And then when we are done reading, or then when we read in something that is not in this range, then we quit. That's the sentinel. The sentinel is going to be a number, an age that is that is 16 through 59. Okay, so here we read in a 12, and that is less than 16. So this is true. And since this is true, then it's going to print out this. So I'm going to just copy this here. Put that here. This works. Okay. And then I'm going to read in another age, and it's going to be 18. And oh, look, 18 is not less than 16. 18 is not greater than 60. So this thing fails. And so we skip over the block, and we print no discount, and then we're done. So we print no discount, and then we're done. Uh-oh. Oh, I got it right. Okay, great. All right, what's this one? Boy, there's a lot of them here. Oh, wow. All right, I'll do one of each here. A variable keep bidding is initially assigned to Y. Within the while loop, keep bidding is updated with the user's next input value. Complete the while loop expression to terminate the loop if the user enters N. Okay, so all right. All right, so oh, okay, let's see what I'm doing here. Okay, so if keep bidding is the input. Okay, so if did I press go? Okay. If keep bidding is not equal to Y, is that what I want it to do, or do I want it to be equal to N? Oh, if the user enters an N. So the user actually has to enter an N. So this isn't enough. It actually has to be, wait a second, this isn't right. Oh, well, it's not equal to N. Yeah, well, it's not equal to N. Wait, what? Within the loop, keep bidding is updated with the user's next value. Complete the loop's expression to terminate the while loop if the user enters N. Okay, so as long as the user does not enter N, then we're going to keep on bidding. So as long as keep bidding is not equal to N, then we're going to do another one. So so someone can type in something other than N. Somebody can type in something other than Y, and it'll accept it as a Y because it's not an N. Okay, let's see what this works. Okay, so you see if I would have, did I not pass all the tests? Why didn't I get the points? Oh, I did get the points. Okay, so so it's not enough. So this doesn't work. If keep bidding is equal to Y, and keep on doing it, that doesn't work because someone can type in something other than a Y. Let's see if this works. Okay, this shouldn't work. But yeah, I see if it does. It does work. Ooh, that's bad. Wow. Hmm. Yeah, this is not the right answer because someone should be able to type in something other than a Y and an N. And this does the wrong thing. Okay, so anyway. Okay, so but I got the points. What's next? Insect growth. Okay, so it's going to be doubles the number of insects. Okay, so we're going to start by reading in some number of insects and write a while loop that in um, each iteration first prints the well, write a while loop that in each iteration first prints, then doubles the number of insects. Okay. The loop executes while values that are less than or equal to 100. Output each new line. Okay, well, I'm not sure. I'm probably going to get confused by this, but let's go. Okay, so the loop is first it's going to print, and let's see, while values are less than or equal to 100. Okay, so while num insects is less than or equal to 100, while this is true, then print num insects, then double the number of insects. Num insects equals num insects times 2. Okay. So and quit when this gets to be greater than 100. So once this gets to be 101 or more, and it'll quit. Otherwise, as it goes, it should. So it'll go. Yeah, this is what it'll print because the next one is 128 and 128 are bigger than. Okay, so that should work. Oh, you gotta. Okay, so you see what I did wrong? You can't have a space here. Okay, that's what this says. It doesn't understand what this symbol is. It knows what this symbol is, but then after this symbol, if it got that, well, that doesn't make sense because this space, the space is going to separate it, so it doesn't make sense. So that's why I got that one wrong. So you can fix it. Okay. All right. What's the next one? Strings are read. This one and this one is read from input. The expected count is initialized to 1. Write a loop that iterates while input is not equal to end, then iterate. So, and we're supposed to count, I think, how many times they're equal. Increment this if this is equal to this, and then read the next one. So while, and so we do it while it's not equal to end. While input item is not equal to end. While input item is not equal to end. Oh, it's got to be capital N. Not equal to end. Then I'm going to, if input item is equal to expected item, then increment count. Increment that by 1. Oh, and then we better read in the next one. We want to read this in. Oh, read input string again. So I only read input string again. Okay. So I just read this one again. And let me get rid of this. Okay, so it's going to keep on reading this until somebody types in capital END. Otherwise, it's going to check to see if what was entered is equal to that. If it is, it increments expected count. And at the end, it outputs expected count. All right, it looks like I got that correct. Let's look at the last one here. Oh, what happened? Oh, never mind. Okay, the next one is iterates while current is less than previous. Okay, so it's gonna so while the next one, so while the current one is less than the previous one, so it's gonna read in one, and then it's gonna read this in. As long as this is, it's gonna keep on iterates. It iterates while the one that it read is less than the previous one. Otherwise, it's done iterating. And iterating means outputting it. Oh, outputting this. Okay, so am I supposed to say that? Well, the sequence starts at this. Then I'm gonna, and I got current in there, so I'm gonna say if while current in is less than previous in, while that's the case, then I'm going to want to print this. Okay, and I'm just going to start with this. And I'm going to say print this, print that, followed by is less than, so I'm going to do this, is less than previous in. Oh, I got to do the period now. Oh, no, yeah, I got to do the period. That's going to mess me up. Okay, so I got to print it out a different way. And I'm not here. I still haven't memorized different ways of printing stuff in, so I'm going to do this. And I'm going to do it this way. Current in plus, let's see, I'm going to say this is a string just in case it doesn't like it. String, str, I think it's str. Current in, right, is, to that I'm going to add is less than, and then I'm going to add previous in plus string, and I'm not sure I have to do the strings, but the strs, but I'm going to do them anyway. Previous in, sequence is decreasing, all on one line. Okay, great, that's on one line. Print that. Next, I'm going to assign previous in with current in. Okay, so I'm going to say Oh, I got to close the parentheses, don't I? Then I got to say previous in is equal to current in, equal to. So that's going to say assign previous in with current in. So previous in equals current in. That's what that means. Previous in equals current in. And then I got to read in the next integer and assign that to it. Okay, so I got to do this again. And then when I'm done, after the loop, I'll put the last integer red followed by breaks the sequence. Breaks the sequence. Okay, so I'm going to just copy this here. And so when it's all over, I'm going to say print str current in breaks the sequence. Hope this works. All right. So one of the things you might notice is, I'm doing it this way, where I'm just making one single string here. I'm just like concatenating a bunch of smaller strings together to make one big string. That to me is easier than doing something like this, where we're doing some sort of formatting and blah, blah, blah. And this is how you output the variable. But, there are things that you can do with this that you can't do with this. So, but one good thing about this grader is that it will accept any way that you get the right answer. And of course, that's a big deal. It's just however you get the right answer. All right, so that's section 5.3. Counting. Okay. So we're done with while loops. Now there's another kind of loop, and that's called a for loop. Okay. There's actually one more kind of loop after that. Do we talk about that? Well, there's some variations to these loops. There's break and continue. We'll get to that. Do we get to talk about chapter 5 next week also? Yeah, we do. Oh, good. We get to talk about nested breaks. Okay, good. So let's talk about for loops. For loops are they're more restricted than while loops. You use for loops when you have a variable that you want to increment in value every iteration of the loop. So if your iteration is going to be some variable, some integer variable that goes from 1 to 10 or something, then you're just able to say in the very beginning for some variable name 1 to 10, and then it does the iteration 10 times, and each time it does an iteration, or each time it executes a block, that variable is incremented by 1, usually. It might not be incrementing an integer by 1. It could be going through a series of sequence of elements of a list. So this is a for loop, and it iterates. This is the block. This high, the name of the person, that's the block that iterates it, that executes each time for each of these values here, 3 of them. The first time name is equal to Bill. Second time name is equal to Nicole, and the third time name is equal to John. So if you see this, how this executes, the first time it executes, it's going to execute Bill, and then it's going to, next time name is going to be equal to Nicole. So it's going to print out that, and then the third time it's going to be equal to John, or prints Adam. So that's how for loop. And so anyway, you can think about how you have something that can iterate through, or iterate through a sequence or whatever, you can very likely, most likely, have that be an iterable variable used in a for loop. So um, so you can iterate through the elements of a dictionary. You can iterate through the elements of a list. You can iterate through anything. Some of them, the order matters. Some of them, the order doesn't matter. Like for a dictionary, the order doesn't really matter, but it's okay. It gets all of them. And so a for loop assigns a loop variable with dictionary keys. Here, this iterates. Here we're iterating through the channels. What we're iterating is this is the key value. The key value. This is the key value. The MTV is the key, and the key. There's key value pair. So there's the key and then there's the value. There's the key and then there's the value. Key and then the value. So when we do the for loop this way, and we just say a variable here, we're talking about the keys of this dictionary. We can also do we can also get both of them. See if it shows it here someplace. Well, we'll see it eventually. If we're just doing a list, then it just iterates through the different elements of the list. Here we've got these integer or floating point numbers in a list. And so this is daily revenues is the list, and this goes for each of the days. And for so each one of these, each time we iterate, each time we execute the block, this day is going to have a different value. It's going to have the next one. Here we're iterating through a list. So the list is called names, and each time the block is executed, name, just singular here, they conveniently have the variable named name. That's what the value, the individual value is as this iterates. All right, so let's do one of these. Okay, so we got this list, and for each weekday, we print. Oh, this is just too easy. It's gonna print thu, then it's gonna print mon, then it's gonna print tu. Okay, so let's do the last one. Okay, so we got a bunch of, it's a dictionary. Nice. So we got a dictionary here, and these are the keys. The keys are the names of these cities. And I don't know what the distance is, distance from someplace. So we're going to loop through cities. And so when we express it this way, city is going to be the key. And if we want the value, we do this. It's just like we're addressing an element in an array, and this is the key or the index of the array, and this is the name of the array. So this is the value for that city. So the value for Montreal is this. The value for London is this. So this is going to be 958 when city is London. So whatever. So again, this is the key, and this is how you get the key's value. All right, so what are we supposed to do here? We're supposed to print out something, right? Okay, so we're going to loop through all the cities. If the city is greater than the distance, then we're going to say, we are looking for the city that's the greatest distance, aren't we? So we're keeping track of this variable called distance. And for each city, we're going to see if this value here is greater than what we currently have for distance. And if it is greater than what we currently have for distance, then we're going to capture that value into the variable called distance. Distance is going to take on a new value. It's going to be the bigger of them. And we're also going to remember the name of the city, the key. So the answer is we're printing out the name of the city, print out the name of the city with the greatest distance. So that would be Montreal. I think this is right. Montreal is print that, and then the distance is 5259. Enter. Okay, it's my guess. Good deal. Okay, very good. Let's see, it's 250. Let's see, next is, I did for loops. Okay, now let's talk about range. This is a shortcut. So if we, if you can define the, you have a for loop, and there's the first thing of the for loop is the variable name, the variable name, which is how you're going to reference the singular value inside the block. So the first variable after the word for is that. So I is the variable that's referenced down inside this block. And then after that, there's this range. Or no, after that, there's the there's whatever it is that we're picking out these different elements from. And so this is just another way to say it's for all of the years in the range years. And so and that would be like if years is an integer, then it's going to be from 0 up to whatever this value is, except for the last value. In Python, we never count the last value. So in other words, range of 5 is going to be this. The first time it's going to be 0, the next time it's 1, next time it's 2, next time it's 3, next time it's 4, and then it doesn't do 5. Okay. What it does do is it does 5 things. This does 5 things, but the numbering starts at 0 and it ends when it gets to 5 things, and so that happens to be 4 because we're starting with 0. And here's another way of saying the same thing, where we actually say that what the beginning number is and what the ending number is. Okay, so this is a more verbose way of saying this. Here, we just assume that the first number is 0, and then it's up, and then the last number is going to be 5. The end point here, since there's only one integer, that's going to be the upper boundary, and the lower boundary is going to be 0. Here, for example, it's 3 to 7. The lower boundary is going to be 3. In other words, we're going to start counting at 3, and then we're going to go up until we get to, but not including 7. So that's why it's 3, 4, 5, 6. So when we talk about a range of 3 to 7, we're talking about 3, 4, 5, 6. Okay, and when we're talking about a range from 10 to 13, we're talking about 10, 11, and 12. Okay, 10, 11, and 12. So you can always get the number of elements in the range by subtracting the top number from the bottom number. 7 minus 3 is 4. There's 4 of them there. 5 minus 0 is 5. There's 5 of them there. 13 minus 10 is 3. There's 3 of them there. Okay, now let's say that you don't want to go up, just increment 1 at a time. Let's say you want to increment 2 at a time. Well, that's what the third number can be. Okay, there's 3 numbers. Normally it's this. Okay, this is the same as this, because you're saying that you're starting out at 0, but that's the default. You're going all the way up to 5, not really 5, but 4. And so that's the 5 there. And each time we're going to increment by 1. So we start out at 0, then we increment by 1 and we get to 1, we increment by 1, we get to 2, increment by 1, we get to 3, increment by 1, we get to 4, and then we're done. Here we're incrementing by 2. So we go 0, 2, 4, and then 6. 6 is beyond this, so 6 is not one of the elements we consider. This goes backwards. This starts at 5, goes down at 0, but it goes -1 each time. So it starts out at 5, 4, 3, 2, 1. So that's what the range looks like that. Here we're doing it by 2, -2 each time. Okay, so that's this range thing, and that's going to be the second thing here when we're defining a for loop. For I in this range. So since it's just one integer, it's going to be whatever the number of years is. Let's say it's 20. The range, it's going to be I goes from 0 to 19. All right, so let's try out one of these things. For I in the range of 5, print. Oh, and then we're going to print a space in between each one. And then when we're just going to print a space in between each one. So we're going to print I, we're going to print 0. Oops. 0, 0, 0, 1, 2, 3, 4, space. Because we print a space at the end. And then we're not going to print anything else, I think. Okay, good. We got that one. Let's do the last one. Oh, we're going to go start out at 0. And then we're going to go to -2. And then we're going to go to -4. Oh, -4 is beyond -3, so we're done. Uh-oh. I decrement by 1, not decrement by 2. Why did I think 2? You audience, the audience is probably going, why did he think 2? Okay, let's try this again. 0, -1, -2, -3, -4. Do I include -5? No, I don't. Oops. There. Good deal. Okay, so it's up to, but not including. Up to, but not including. Or in this case, because it's negative, it's down to, but not including. All right, what's this last one here? Counting using the range function. Positive integer minutes up is read from input. Minutes up is read from input. That number represents the number of minutes lapsed since the recording starts. Complete the range function call so that the for loop iterates through the increasing sequence of all non-negative integers less than or equal to minutes up. Okay, so less than or equal to, it's all of them less than or equal to minutes up. That means we're including minutes up. Well, I'm going to do this. I think it's going to be range going from 0 to start. Well, I don't need the 0 because I'm starting out at 0, aren't I? But we're going up to minutes up. But we're going to we want to include minutes up also. So non-negative less than or equal to minutes up. So really, the range is not from 0 to minutes up, because if we were to put 0 to minutes up, we would not be including the last number, which is minutes up. But we want to include, it's got to be equal. So I'm going to say minutes up plus 1. Plus 1. How's that? Hey, all right, yeah, all right. Okay, let's do the last one. Okay, integers start item and stop item are read from input. Start item and stop item. These are representing the items in an assembly line with start item less than stop item. Okay. Every fourth item between this and this, inclusive, means we're including the last one. Output checking item, followed by the item's value. Okay, checking. All right, let's see what happens here. Boy, that's hard. Every fourth item, so 4 item in range 0 to, I got to put the 0 because I want to put every fourth. So since I want that third parameter, no, this is argument. Since I want the third argument, I got to put the first one in there too. So 0 all the way up to stop item. Oh, wait a minute. Between start item and stop item. So I forget what I said. We got to put start item, comma, stop item, inclusive, +1. Every fourth item, 4. All right. And what we're going to do is we're going to type print. Checking item, colon, quote, comma, I. Okay. See if this works. All right, very good. Okay, so that is okay. So now the next one. Okay, so the class is over. But I'm just gonna quickly. There's a debate tonight. It's 9 o'clock Eastern time right now. So here, this just end. You should just read this. It talks about the difference between while loops and for loops, and how sometimes sometimes you have to use a while loop, but lots of times you can just get by using a for loop, and that kind of simplifies things. For loops are simpler. It's easier not to mess up. It's easier not to make a mistake using a for loop. It's easier not to it's easier not to write a infinite loop accidentally with a for loop. But again, a while loop, you can do things like you can have a sentinel and all that kind of stuff. You can't have a sentinel with a for loop, really. So you should read this. I'll never test you on it, and I can't think of any problem that you're going to be faced where you have to use a while loop and you can't use a for loop, or you have to use a for loop and you can't use a while loop. The loop that you use will just come more or less naturally to you eventually. If it doesn't matter, because if it works, it works. And if your thinking works that way, that's great. So I'm going to end it here, and we made it all the way through 5.6 and 5.7. After this, we have some labs. So I'll check to see if these labs are if there's videos for these labs already. If they're not, I'll touch on them next time. Otherwise, next week we should go over these. Start with nested loops. You can have loops inside of loops, and that's what we're going to learn about. All right, you guys got any questions? How many times did I walk around KCC? You notice my background? I'm walking around KCC. I have a walker at home.
Yeah, that's funny. That's pretty funny. It looks good.
Okay. All right. So I'll see you next week, if not sooner. Okay. Take it easy.